Hi guys, and welcome to this session by Intellipaat. So we live in a world where containers have taken over the whole deployment industry, right? The IT industry, everywhere there is containerized environments, and we live in an environment where DevOps culture is highly appreciated and adopted by almost all of the Fortune 500 companies. So today we have taken one such DevOps tool, which is used for container orchestration, which is called Kubernetes, which is heavily in demand, has a very active community. People are posting a lot of updates and helping each other out. So today we'll be discussing about what is Kubernetes, and we'll talk about different aspects of Kubernetes. We'll go through various very simple basic concepts of Kubernetes, and then we'll talk about different hands-on and stuff like that. But before we get into all of that, please subscribe to our channel to never miss an update from Intellipaat. Now, let's talk about today's agenda. So today's agenda is fivefold. So we'll begin with why do we need Kubernetes? In this section, we'll be talking about how we came about requiring Kubernetes. So we had some deployment eras before we went into containers. So we'll be talking about how the need for Kubernetes even began. We'll be discussing that in our first section. Moving on, we'll talk about what is Kubernetes, and then we'll move on and talk about different concepts in Kubernetes, where we'll cover pods, deployments, services, and Ingress. And then we'll have a demo where I'll create all of these pods, deployments, and one service and an Ingress, and we'll see how it works in real time, right? And then finally, we'll have a further learning section where we'll talk about how you can go about learning Kubernetes and different free materials as well as paid courses that you can look at to learn Kubernetes, right? So let's begin with this session. So why do we need Kubernetes? So to understand why the need for Kubernetes even began, we need to go back in time and see what people did initially. So humans, as we know, evolve a lot, right? We make something and then we see an opportunity for improvement, and then we go about improving that over and over again till we become the most efficient as we can, right? So when we started this deployment era of ours, we started with a traditional deployment, and then we moved on to a more virtualized environment, and we had then finally arrived to the container deployment. So these are the basic three eras that you can boil down to when it comes to deployment, right? So let's talk about all of these. So first that came about was traditional deployment. So initially all the organizations that were there, they were using physical servers, and all their infrastructure and everything was on physical servers, and there was no ways to define boundaries between resources for one application from the other or one requirement from the other. So that created a lot of, first of all, it was very costly to have like physical server running one application. Second was resource allocation was a huge issue. So people thought maybe we can do something better. That is when virtualized environment and VMs came into picture. So in this methodology where we talk about virtualized environment, we are basically running multiple machines on a single server. So you are running multiple VMs on a single physical CPU server, right? So what it basically allows you to do is you can isolate few resources among these VMs, and this provides a level of security as well when we talk about in terms of security between applications, because it makes it more secure, because one application is different from the other since their resources are also divided. So and applications cannot be freely accessed by another application because they are on different virtual machines, right? So you can see the architecture that we have mentioned here for virtualized deployment. So we had hardware, then we had operating system. On top of that, we had hypervisors, and then we have two different virtual machines running our applications. So that is that. And then when we were doing virtualized things and things were looking right, at that point of time we realized that there is something that we can do even better. So you don't actually need a lot of the resources that are there in a virtual machine or a physical server for that matter. You need some particular let's say set of libraries which are very lightweight, and you can use that to run your applications. So that makes your entire process more efficient as well as less space consuming as well. So that is when containers came into picture. So similar to a VM, a container has its own file system, a CPU, a memory, processor, and more. So as they're decoupled from the underlying infrastructure, they are more portable across clouds and OS distributions, and they are very lightweight. So that is another reason why people shifted to containerized environment. While a VM might take, let's say, about 1.5 GBs to 2 GBs, a container can be as small as 80 MBs. So that you can see is a huge different amount of space that containers is saving for you from virtual environments, right? And then containers have also this relaxed isolation properties to share the operating system among their applications. Therefore, they're also considered lightweight in that aspects as well. And then there were a lot of different features that comes with these containers. So as you can see, for agile application creation and deployment, they are loosely coupled. So you can have liberated microservices which are independent of each other and work very well. You can have application centric management. Let's say if your application has like many smaller application sites, so you can have an dedicated team for a different smaller applications, so that will create more application centric approach. There will be environmental consistency since everybody will be working on these small containers, and so there will be no discrepancy between the environment, let's say what I am using, and and the other guy who is in, let's say, in development or operations. So that gives us the opportunity to have environmental consistency throughout the organization. And then you can have move your things to cloud and different OSs. So that also gives you another cloud and OS distribution portability. It allows you to have resource utilization as well as isolation. And finally gives you continuous development, integration, and deployment. So that is why people started using containers, because of the so many features that it provides. It gives you so many different benefits, and that is the very simple reason why people switch to containers. And now we have a lot of different applications which can create containers, like Docker is another tool that creates containers, right? And there are many different like that. So people are now shifting to containerized domains. So which brings us to what is Kubernetes. So now we've talked about that we have various applications running on these containers, right? So any simple application if you create, and if it has like multiple layers to it, will have like a lot of containers running. So for that matter, what was required was something which can bring together the management of all of these containers. So that is when Kubernetes came into picture, as it is a container orchestrating tool. So Kubernetes is basically a very portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. It has a very large and rapidly growing ecosystem, and there are a lot of support and tools available out there, and the community for Kubernetes is amazing. People are out there who will help you very rapidly and vigorously, because people are there to make sure that this open source environment gets all of the attention that it can. So that is what basically Kubernetes is. Kubernetes basically provides you with this framework to run your distributed system very resiliently, and it takes care of all of the scaling and failover for your application, and provides you with deployment patterns and more. So what we basically mean by scaling and failover of your application is, let's say you have an application, right, and you're experiencing heavy traffic, and for some reason one of the deployment pods which you have, pod is something we'll be discussing later. So let's for now just understand, like you have something like a simple web application which you have put a HTML page which is failing for some reason, and it failed, so it basically your pod stopped working. Generally, if that is the case, it will stay stopped working, right? But what Kubernetes does is, if it notices that any of your pods or services, anything which is not working and it fails, it basically restarts it, it deletes it, and it makes sure, let's say if you define like you want 4 replicas of a certain pod, it makes sure that there are always 4 replicas available for you. If it is less, it will make a new pod for you. If it is more, it will delete the extra pod and make sure that whatever configuration that you have defined stays input, right? Moving further, we'll talk about few basic concepts in Kubernetes now. So in this section, we'll be discussing very simple concepts related to Kubernetes, like pods, deployments, services, and ingress, right? So let's talk about them now. So basically, a pod is the most basic execution unit of a Kubernetes application. It is the smallest and the simplest unit in a Kubernetes object model that you can create or deploy. It basically represents process of running a process running on your cluster. That is what basically a pod is. This is the smallest element that is there, right? And talking about deployments are an upgraded version or a higher version of a replication controller. Now, replication controller is something, let's say you wanted to create a pod. Now, for this pod, you want at least 3 or 4 replicas running at all times, so that You can have better load distribution and whatnot. So in that case, a replication controller, what it does is it makes sure that if you define, let's say if you want 4 replicas of your pod, you will always have 4 replicas of your pod. Now, deployment is something which is an upgraded version of that. It basically makes sure that your replication is maintained, but it does it with the help of replica sets, which is another upgraded version of the replication controller. They also have the ability and the capability to update replica sets and are also capable of rolling back to the previous version. So let's say you're working in an environment and now your company decided that you want your whatever the image that you're using to be, let's say you have created a web page and you call that image 1, right? And you go through some system updates or the web application updates and you change the UI somehow, and the second image you call it as image 2. So what deployment basically allows you to do is, if you want to, let's say, go to the new image, you can do that with the help of a deployment by running a very simple command on it. You can just type out that you want to update the replicas, update the image version of this particular given deployment, and you can do it from command line. You can go about doing rolling updates as well, go and rolling back to the previous version. So if, let's say, the new image that we created wasn't working out or had some bugs, so what you'll do is instantly run a command and go back to the previous version of the image that you had. That is another advantage that deployment gives to you. And there are a few different ways with which you can basically make changes to your deployment. So you can update it, you can delete it, you can either roll back or as well. So that is something which deployments provides you with. Moving further, we have something called services. Now, services can be thought of as a logical set of pods. So it can be defined as an abstraction on top of the pods, which provides a single IP address and DNS name by which pods can be accessed. So with service, it is very easy to manage load balancing configuration, and it helps us to scale pods very easily. So let me clarify this even further for you. So basically, when Kubernetes runs, and if you go about learning about the architecture, so it basically communicates internally with itself. And with service, what happens is you don't actually need to know where the pod is. It will tell you that you have access to, let's say, a number of pods, but it is not telling you actually where the pod is. It is giving you a logical representation of, yeah, this is the pod which is present for you, and you can go about hitting and getting back the response that you want. But it will not tell you where actually the pod is situated at. That is what basically the job of a service is. It will tell you, it will show you a logical set of pods, and it will help in load balancing, and it will get you access to all the pods with a single IP address, right? A service can also be thought of as a REST object in Kubernetes, whose definition can be posted to Kubernetes API server on the Kubernetes master to create a new instance. And the set of pods targeted by a service is usually determined by a selector. So when we define service in our hands-on section, I'll show you what do we actually mean by a selector. And when you are working with Kubernetes, so there are a lot of times you'll be reaching out to different services or pods, and you'll be using something called as a selector to find out what that application is. And you need to define your configurations properly in a YAML file while working with Kubernetes, and this is something we'll discuss while going through our hands-on section, right? So moving further, we have something called as an Ingress as well. So Ingress is something which can be configured to give services externally reachable URLs, and to balance the load, and to terminate SSL and TLS. And it also offers you virtual name-based hosting as well. So what do we mean by this basically? So there are different kinds of services in Kubernetes as well. So there is cluster IP, there is node port, there is load balancer, there's more. And so what happens is basically a cluster IP kind of service, which is a basic service which you define, is not externally reachable. It is reachable inside of the cluster. So a cluster will have a master and a node. That is what you do with Kubernetes, and you have a different set of nodes which are running different pods. And if you want to reach within these clusters, like if you want to, let's say, talk to node 1 or node 2, you can get that data back. But if you're trying to reach something from the internet, that will not work for you. So that is when Ingress comes in handy. It basically routes the external traffic to a service and gives it an externally reachable host. And what we mean by virtual based name based routing is you can provide names. Let's say http intellipaat.com/ let's say Intellipaat1 is one way to reach one service, and Intellipaat 2 is a different service. That is something on the basis of the name that you can reach different service is what Ingress provides. And we'll be looking at that while we do the hands-on. So we have a basic virtual name-based routing set for you based on an Ingress that we'll show you when we move to the hands-on section, right? So that is what basically an Ingress does. It will allow you to help, it will basically help you with the load balancing, and it will give you an externally reachable URL that you can reach from the web so that you can get services which are not exposed to the internet. So an Ingress does not expose any arbitrary ports or protocols. So this is something that you should know. It does not expose any arbitrary ports, and exposing services other than HTTP and HTTPS to internet typically uses a service of type node port or type load balancer. So if you want to expose your service, let's say, to the internet, you can do it through node port. Or if you have a cluster IP kind of thing where you want it to be hidden, then in that case you can use Ingress to route it to a cluster IP kind of service and then move on from there, right? So now let's move on to the hands-on section where I'll show you various different things related to Kubernetes. So we've talked about pods, deployments, service, and Ingress, right? So we'll see all of these one by one, right? So let me show you the YAML configurations first. So I have YAML files which I have created here. So this is basically what a YAML file looks like for a pod. So what you have to do is this is a very basic kind of YAML file which we have defined here. So you have to necessarily give an API version. You have to define what kind of thing it is that you are trying to create. So in this case it is pods. So if you look at the deployments, you'll see it is mentioned as deployments. If I go to service, here you can see it is of the kind service, and if I go to Ingress, it is of the kind Ingress, right? So this is how it looks like. And while creating YAML file, you have to be very careful with your indentation. So 1 spaces and 2 spaces has to be there. If you let's say make any mistake in indentation, your configuration file will not work whatsoever, right? So in this pod, what we have basically done is we have created given it a name which has a metadata as Intellipaat. So when I create this pod, it will show a pod of the name Intellipaat was created, and I'm pulling an image of a web app which we have created. So let's see how we can create this YAML file. So what we got to do is basically copy this. I have already pre-installed Kubernetes here in my service. So if I do kubectl get pods now, you will not see anything in the default namespace, right? So what we have to do is we have to create this configuration file first. So nano pod1.yaml. So what basically you have to do is, like, nano is for creating a file, and pod1.yaml is the name of the file. You can name it anything you want, but .yaml has to be there, right? So if I go here and I have pasted my data here, so you can see it has the version 1 and pod metadata configurations and everything. I have created it here. I'll just control S it real quickly and control X, go back. Now to create a pod or anything, you have to use the command kubectl create, and then since I'm using a file, -f pod1.yaml. As you can see, it says pod/Intellipaat, which is the name of my pod in the metadata. If you can see here, Intellipaat. So that was created, right? And if you want to see different details about this pod, you can do kubectl describe pod and the pod name. And you can see the different details about this pod. So if you can see, it has the name of the Intellipaat. It is in the default namespace, and you can see the IP address of this, and you can see the state, if it is running or not. If there was an error, it will show an error also here, and the different things related to it you can see inside of this by using kubectl describe pod and then the pod's name, right? Similarly, if we wanted to create, let's say now I've created only one pod. So if I do kubectl get pods, it will show me only one pod is running, right? So one pod which I've created. Let's say you wanted to create multiple pods. So in that scenario, what you can do is you can create a deployment, which brings me to the deployment YAML. So as you can see, I have Nginx deployment running here. So this is the YAML file that I have written for Nginx, and it has 3 replicas. So what our expectation here is, when I deploy this, there should be 3 pods with the name of Nginx which should be running, right? So let's see how it works. Just quickly copy it real quickly, and we'll go back to our putty and just clear it out for you. nano deploy.yaml. I'll paste that real quickly. So this is here, and Control S, Control X, get out of there. Then kubectl create -f deploy.yaml. As you can see, it has created Nginx deployment. Now, if I do kubectl get pods, I should be seeing 3 different replicas of it. So kubectl get pods. So as you can see here, we have 3 different pods with different names though, running inside of it. And you can see Nginx, this is the 3 deployments. This is the 1, 2, and 3. It was all created through one particular single deployment file, because I mentioned 3 replicas here. So you can also scale this deployment according to your needs. So what you have to do is you have to use a very simple command, which is kubectl scale, and then -- replicas, because I want to upgrade the number of replicas we have. And whatever the number you want it to be, it's that currently it's 3, so let's make it 5 just to see how it works. Then name deployment, and then your deployment's name, which is Nginx deployment, right? Let me copy it, and boom, it has been scaled. So if I do kubectl get pods now, what I'll get is 5 different replicas. 1, 2, 3, 4, 5, right? So that is how you basically scale a deployment. As simple as that. Now, talking about services, so now what we will do is, instead of just showing you services, what I want to do is show you virtual base routing with the help of an Ingress. So I'll create a service. I'll create basically 2 services, then I'll route an Ingress around it so that we can see how virtual name-based hosting works, right? So let's do that real quickly. So I have 2 services I have defined here. So if you can see, I've defined the pods here, the spec containers. I've given it the name of Apple. So the first service is echoing the text as Intellipaat 1, and it has the name Intelli here. And the service 2 will be echoing Intel 2, right? These are the 2 services that we have created. So let's copy this real quickly and create these files as soon as possible. So nano svc service 1.yaml. Paste this, Control S, Control X. Similarly for second service also, I'll do service 2.yaml. I'll go back, I'll copy the service 2 which I have created, and real quickly, and come back here, paste, Control S, Control X. So what I have to do now, I have to create these services. So kubectl create svc kubectl create -f service 1.yaml, right? This should create a service which pod Intel 1 was created, and service called Intelli 1 was created, right? Similarly, we have to do for service 2 as well. Now we have created 2 services. So if I do kubectl get svc, I should see 2 services of the type cluster IP. Now cluster IP is something that you cannot reach externally, right? So even if I try, I cannot reach this service from the internet. That is when Ingress comes into hand. So what you have to do is you can use an Ingress to define it over a service, and you can give it an externally reachable host, right? So for that, I've created another YAML file for Ingress. So in here, if you see the Ingress example, you can see I've defined 2 rules. I've given it 2 paths. So the first part is Intelli 1 and the second path is Intelli 2, right? So if I go for a name-based hosting, I should see the result of the Intelli 1 service in if I go \Intelli 1, and if I type the path 2, then I should get Intelli 2. So what will happen is, if I go to the service 1, that is Intelli 1, I should see an echo which says Intellipaat 1. And if I go to Intelli 2, I should see what the text in the service 2 is, which is Intel 2, right? So let's make this Ingress real quickly and copy this one. Go back to the putty and let's clear this out. nano ingg1.yaml. Just paste this real quickly, Control S, Control X, create this file, kubectl create -f ingg1.yaml. So it says Ingress has been created. Now, what I want to do is I'll open a Mozilla Firefox. I have Firefox here. I'll open Firefox real quickly. While it opens, what we have to do is we need to go to a particular IP address of my master, which is here. I'll go to my master's IP address. This is the public IP address of my master, right? I'll paste it here. But doing this, we'll not get anything. We need to find the port where our particular service is running, right? So for that, what you have to do is you need to get the service name for the Ingress. So you won't find kubectl svc, get svc. If you do, you wouldn't find the Ingress service which I've created, because it's not in this particular default namespace. So what you have to do is you have to write kubectl get service -all -namespaces. So this will allow you to get all the services which are running in different namespaces. So if I go here, you can see my Ingress Nginx is running, and it is of the type node port, and it is defined at this particular IP address, right? So if I just go here, colon paste, and if I type what was our definition, which is path was Intelli1, you should see an Ingress which returns the value Intellipaat 1. This port wasn't created. Let me check. It's of the type 443. Just copy it again. It's routing to my current master. Saying bad request for some reason. Let's see if I copied the path correctly. Intelli1 I did copy. Did I copy the IP correctly? Go back to my port. This is the 443 port. Okay, I understand what is wrong. So this is of the type 443. So I have noticed my error. So it is of the type 443. It won't run on the normal HTTP. So for running this, what you have to do is to do HTTPS -:. Because of the type, it won't route to the HTTP. It will route to this place, right? If I do now Intelli1, it should run. And I go here, I just paste it, and you can see it's now working for us. You have to accept the risk, and you can see Intellipaat 1 is here. So if I do it for the other one as well, which is my second part, I should get Intel 2 as the output. And you can see the output is Intel 2. So keep that in mind if you are routing for 443 port, which is I just saw here. So if it's of the type 443, it always routes to HTTPS. Keep that in mind, right? So let's get back to the session and finish with the final words. So that was about the demo. So about the learning path. So now I've told you what Kubernetes basically looks like. So you'll be interested to know where you can learn about Kubernetes and how you can go about learning Kubernetes and in detail and in depth. So we at Intellipaat care about your learning a lot. So that's why we have carefully created a course for you where we have covered a lot of different things about Kubernetes in detail. So you can just go to our website here and you can get the details of our course. So here we give you 24/7 lifetime access. So if there is any time where Kubernetes goes into any upgrade, so you can come back to us anytime you want and you can study with us. We also give you 24/7 support. So if you are, let's say, studying at 4 in the morning and you get a doubt, you don't have to hesitate or Google. You can just reach out to our support team real quickly and we'll get back to you as soon as possible, 24/7, 365 days, right? And we also give you the option of working with self-paced, where you can learn at your own pace. And you can read about the different details of the course content that we'll be covering. So we have scaling apps, deployments, we teach you taints, YAML. We also teach you how to connect your Kubernetes with monitoring services like Prometheus and Grafana. And we'll teach you how to create a YAML file, and Ingress and whatever you have learned will also be there and more. And we'll teach you how to create persistent volume, secrets and whatnot. So if you enroll with us, and if you complete this certification with us, you will receive this certificate, which is industry recognized certificate by us. And you can just go on to our website to check it out. And let's get back to the presentation and let's finish this one real quickly. So for the learning, so if you were, let's say, wanted to know more about Kubernetes before you got about learning about or taking a training course with us, you can reach out to our blogs as well as YouTube channel, where we post content about various different technologies which are trending right now. We also teach BI tools, data science, machine learning, you name it, we are there everywhere. So you can read about different technologies for free on our blogs, or you can go to our YouTube channel and get video tutorials on various different things. We also have various versus videos where we compare and contrast different technologies and different things in a single domain. Let's say if you're working on cloud and you're wondering which is better, AWS or Azure, you can just go out to our website and learn, or go out to our YouTube channel and learn about it very easily. And if you have any technical doubts, we also have a very active community. So if you want to, let's say, ask about any doubt that you have, you can just go on to Intellipaat community and post your questions there and get answered by us as well as our community members, which are very active and very influential. And finally, if you want to get any discount, we are running YouTube 30 coupon, which will give you flat 30% off on our courses as soon as you apply. So YouTube 30 to get 30% off right now. If you are interested, just go ahead and buy our courses and use YouTube 30 to get flat 30% off. And finally, if you have any questions or want to talk about your personal resume and which courses will suit you, you can just reach out to our support team for free. And the numbers are on your screen. You can call us about any doubt, or you can reach out to us through email as well. Just write down to us. And if you have any doubts or queries, we are happy to clear it for you. With that, I'll be signing off. Thank you so much for watching.